Hello, everyone. Before we get started, how many here like to work with the CSS? Okay, few, but not many. That's good, because in this session we will see how it's possible to streamline the extraction of Figma mocks into code. Typically, teams and organizations have to face three main challenges when doing this process. The first of all is duplicate work. Designers provide UI layouts, and then developers have to take and manually implement them in code. This step is even worsened by the lack of automation that creates some sort of async flow. If the designers need to update the mock in Figma and then don't communicate the changes quickly to the developers, what it happens is that there is some sort of discrepancies between the final generated code and the updated layout. This brings to the third challenge, that is coordination challenges, due to this manual handover. And often, and this happens very often, at least in the projects I had worked on, is when the business also steps in and asks, okay, I would like to refactor this layout, I would like to have a different wording. And therefore, things get worse. And exactly in this context, Builder.io steps in to solve exactly these challenges. We can see here an overview of a typical flow. Builder.io, the company, provides a so-called develop flow. Develop is an AI-powered, designed to code flow or process that allows to start from Figma, and thanks to the Figma plugin, we can extract a Figma component into a Builder.io infrastructure, also called the Builder.io space. At this level, we can then leverage the structure layout, maybe adding further UI elements or content. And then we can, thanks to LLM, we can generate the code. And we can target most of the available or famous frameworks, so Angular, React, Vue, and others. Finally, we can synchronize this generated code via LLM to our repository. So these go in one direction. However, as you can see, the sync-to-code arrow has a bidirectional flow. That means that we can even, and this is very important, we can even map our existing code component to Figma component, so the other way around. What does it mean, or this effect of this, is that when then we extract a Figma component now that has one or more of these mapped component, then the LLM will leverage this knowledge and will reference simply one of these existing components rather than generating a new. It could be a button, could be a checkbox, or even a more complex UI element. This is something that many of the AI tools out are not capable of doing. All right, before going on, let me introduce myself. My name is Francesco Leardini, and I work as a consultant and trainer at Accenture based in Switzerland. I like to focus mainly on web, not Java. Web, so architecture, optimization, performance, and recently also play around with AI in the browser, that I find it's a quite interesting new field. That's it. We won't have any more slides. Now it's only hands-on in the demo. The first demo we will see, it's a design to code. So we will start exactly reproduce the flow that I described before. So we go from Figma, we extract in Builder.io space, we let the generate code, and we synchronize with our demo application. For this session, our demo application is a simple Next.js React project. I have to mention, though, it will be quite, at least for me, a very thrilling demo. The reason I will tell you later, after the session is finished, unless we all see it during the demo. So let's leave a little bit of suspense. This is for later. It's big enough for all. Actually, we don't have to focus on the code. It's not important. It's more the process. Here, as I said, is a simple React application. We have just a main page with some already existing React components. How the application looks like, nothing fancy. But with this demo, I wanted to reproduce a possible real-world scenario or project where we as developers, already created some UI elements that are then reused across our project. So this is our starting point. Let's now go to Figma. In Figma, I don't know whether you're aware, but we can install plugins using the plugin menu and then manage plugins. And then here in the plugin and widgets section, we can search for all the different plugins available. The one we are interested in, of course, is the Builder.io plugin. And then we can download and install it. Once it's installed, we can select a Figma component we want to extract. And then we go over plugins and we run now the plugin. At this stage, we can see here, bottom left, I am already logged to my space. So this Builder.io space that what we saw before is the space where we extract now the layout, and we can then go and further leverage and work on it. I'm already logged in. So I can export the design. Now the plugin will analyze all the hierarchy of Figma layers, and then I'm now available, or I can use different output commands, either via CLI. This is possible thanks to the Builder.io DevTools npm package that I already installed on my project. And so I can copy this CLI command and let it execute straight in the terminal of my IDE. Or we can copy this extraction and we open it now in the Builder.io space. This is how does it look like. I copied it here, and as you can see, okay, the contrast maybe on the Beamer is not that much, but as you can see is exactly close or very close to what it was the original template that we added here. Builder.io space has two main modes. This one is the, as we can see up here, is the edit mode. In this screen, or in this mode, we can leverage the extracted layout and enrich it. So we can add the new fields, we can add the new parts. But we will see that in the next demo, so we skip it for now. Now we are more interested in the develop mode because we extracted this layout, and now we want to create React code out of this. On the side panel, we can indeed select the target framework. We stick with React, but we can have Angular or others. Tailwind, because we use that also in our project. The language, TypeScript. And we can even decide whether to have or not a unit test set it up for us. Then we have a two code output. The default one is quality that leverages and uses the LLM capabilities. Or we can even have, if we want a much faster result, the fast code output that does not use LLM and uses only a compiler called mitosis. And the result, of course, will be almost immediate. Very important is the section underneath, where we can provide some global rules or style guides, so that here, for example, in the match code style, we can provide some examples or code snippets so that the LLM can now follow our style. General instructions are global rules that create some sort of guideline for the LLM. Here, for example, when I target Angular as a framework, I specify that I want all the styles and the templates files be generated in independent, separate files and not having everything in one class component file. Otherwise, this would be the default behavior. So these kind of rules, you can put it here so that you can much more precisely say how the LLM should generate the final code. Another very important aspect is the possibility to use some predefined accessibility rules or even define new ones. These, aside to the automatic responsiveness of the generated output, makes us so that we can really save a lot of time. Think about not having to think or to care about that our generated code is responsive and accessible. All these aspects are already made by the LLM, by this tool, for us in the generated code. So now we define these global rules. typically we just use at the beginning of the flow of the project, and we don't have to touch them every time. When we are done with them, we can generate the code. Now the LLM will start planning the generation and follow all the instructions we given and start generating the React application or the React component. We can see there is a form legend, and then we go on with there will be a form input, there will be a select, and so on and so on and so on. Once the generation is concluded, if we are happy with it, we can just extract the code, or we can use the input field underneath to provide some prompts and fine-tune or change the generated code. As a rule of thumb, here we should provide more broad instructions. If we want to change small granular parts, then better do them straight into the code because it's much faster. All right. One important thing is this one I mentioned before. We generated a lot of custom components, but here, remember the name, custom button. Probably from the back you cannot see, but we have here a component called a custom button. This is a component that we had in the code and had already been mapped. Let me just zoom in it so you all see it. Right. So we have this custom button that is not something that has been newly generated, but is something that I had already in the code. And if we go back, is exactly that, line 28. So I had already mapped from my local code to Figma this component, and this is to prove that now when I do a generation, what the LLM does is not generating a new custom component as the others, but it will just reuse that. So with this functionality, we are sure that all the layout rules are, respected across all our project. Once we are happy with the generation, we can sync the code, and we are provided with a CLI command that we can run on our IDE, and this will recreate locally all the generated files. Yes, I want to proceed. Okay, Wi-Fi is not the quickest, but in the meantime, I can tell you about something else. So what we will do now, we extract, we generated the code, we extract and save it locally. Where do I want to save it? I want to save in a form folder under the components folder, and we have all the files generated underneath here. How good it is this generation? We can quickly test it. We go in our page, and I copy it here. All right, I import it. One error that it did not, so it created a custom component, but it did not reference it. It's good, but it's not perfect. All right. How does it look? It looks almost good. So as you can see, sometimes it works very well, it's pixel perfect. Sometimes there are some CSR rules that are lost into the way. And this is what I said before. I was a little bit thrilled or having a little bit of chill while doing this demo, because something like 1 week ago, the team introduced a regression. And I had to experience that exactly while I was rehearsing again this demo. But the team is working on it, and they ensure that this should be fixed like in a week or so. But let's imagine now that in any case, these borders or so would have also been correctly imported. As you can see, the delta that we would have to provide or to work with is extremely small. And in a matter of minutes, we were able to extract a completely brand new layout from Figma to our code. And this is to go one way. Now, if we wanted to map another component, how can we do? For example, now we want to map an input field, for example, as we did already before, or as I did already before for the button. We open again our Figma plugin. We select the component, or we can even select the whole Figma component and then going in the ID one by one. But here we select only the input field and we click on the map button. As we can see here, nice. As we can see here, we have already one mapped component that is our custom button before. Now we have another CLI command that is to map now the Figma input component to our local generated form component. It's a little bit longer, and with this token ID, we go and identify univocally our Figma component in the Figma file. We go and fetch all the information, and now here we can see, okay, select which is the target local code component that you want to map to the input field. In purple is the Figma component. And then we have different possibilities. I want just to describe one very interesting one that is also the possibility to map to an external NPM library. This is because the case that we described so far was when we defined and created the UI elements. But sometimes we rely on third-party libraries like MUI design library for React or Angular Material or other UI libraries that are not developed by us. In this case, we can say that we want to map our Figma UI component, button, checkbox, and so on, to this UI library that we are using. So targeting the external NPM package that is installed locally. In our case, we have locally created the form input, therefore we go on with that selection. We can provide the documentation, the URL documentation for the mapping or for that component so that the LLM has even a better context. Here, for this demo, we don't have it. The output of this command is a mapping function. What this function does is taking all the Figma properties and try to map to the local code component properties. Of course, depending how we define the interface of our local code component, some will be matched and some not. Ideally, the mapping or the match should be 101 so that this automatic flow or function will map them all at once. Here we have only placeholder and label. If we are happy with that, we can just write good in the terminal. Otherwise, if we wanted to enhance, for example, we wanted to have some conditional check, and according to that, we provide one or the other mapping value, we can do so by prompting in the terminal. But here we say, okay, we are good. We can save this mapping function locally. It will go by default in the mappings folder. And then, as a last step, we can publish this mapping so that it will be then be active also in Figma. So this is exactly the step or the steps I did before to map the custom button. Yes, I want to publish. We can see that he already found the two existing mappings. One was button and the other one is input field. And now if I go back to Figma, we can see that we have two mappings now. And if I select the whole components, we have indeed this input field, the new mapping aside of the button. This is important because let's imagine this kind of layout, much more complex. We started mapping the button, but the button, we have it here. Maybe that one is just another variante, but is the same element. And then we have input field that we start mapping and so on. Let's say 80% of these of the little elements of this huge landing page are mapped. That means that when then we extract and let's generate the whole landing page, there will be 90% of just reference to this button, to this input field, and so on. Therefore, the LLM will generate just a small part of custom and freely generated elements. All the rest will just reuse and reference these existing code components. Therefore, we can really ensure that all these UI elements will be, and the UI rules will be respected across our project. And this brings to the second demo. Another scenario that I found very interesting that is possible with Builder.io develop flow. The possibility to, and very easily, to create interactive prototypes. Let's imagine our product owner or project manager wants to verify and prove a specific new UI flow. In this case, it's possible to create an interactive prototype without asking anything to developers. So not only that the business stakeholder does not have to have any technical background or knowledge, but also it can create a complex UI, clickable interactive UI, without having to ask anything to developers. Typically, otherwise, we have to interact with developers to create very simple sketches or clickable prototypes. For this, we go back to our Figma file, and we get a little bit more complex page to start with. We get this landing page. Again, we want to export it. We go and analyze the whole page. We prepare the metadata, and then we can import it into our Builder.io space. This time, though, we will focus on the Builder 2, yes. This time, though, we will focus, all right, it was almost good. We can see that the buttons are a little bit more stretched and so on, but almost all good. This is nice of the live demo coding results. This time, we will focus on the edit mode. Now, let's imagine we start with this sketch. Our project manager starts with this as a base provided by the designers. In the panel here, we can interact with an AI assistant called Visual Copilot. And we can ask something. Like, for example, we can say, add a table with 2 columns under the title. With 2 columns, and we want to have like name and image. All right, that is new. That's nice. It was not here this morning. So here we can create like an example. So an example of a website eventually that we want to use as an inspiration. Could be the Apple website, could be the Google website, and so on. This morning, though, I was not prompt for that, but okay. Now, the Visual Copilot takes our prompt and will add into the UI our request. The next step then, once we have this table generated, will be to use, here we are. We have a table with name and image. As we can see on the right side, this we didn't see before because the layout was a kind of a form, but was already kind of mobile. We can see here, as a default, we have a desktop version, and the structured layout is already responsive. So in the mobile version, we have kind of all the elements vertical aligned. We can restrict this, and it should go on the tablet version, and then even all the way to mobile again. So this to show how it is also fully responsive. An interesting other functionality, now that we created this table, is the possibility to provide APIs. APIs that maybe comes from our server, so that provide mock data or even test data that we can use to create this prototype with meaningful business data. So not just the lorem ipsum or static data, but maybe business relevant dynamic data that come from an API. For this, I will uncomment this. And we will use in the demo the Faker API that just grab 5 products. We can provide the output here so that the LLM knows also the context that will be provided. We can save it, and we can add it by clicking on the instruction button down here. Now we can say, okay, fill the created a table with the provided API. And then we can say even to use a specific field to target a specific part of the layout. For example, use the URL value of the first element of the data arrays for the image cells. Okay, it's a relatively long prompt. But this is to show how we can not only use the response or the data that comes from the response, but we can even match some of the fields from this response payload to some of the fields of this UI. So to enrich it and to make the prototype really as much as possible closer to what it could be like a final production-ready code or UI version. We can see here we have 5 results. The image is broken probably because it didn't grab correctly the data from the arrays. But if we open it again, we can easily correct it. But it was good data images, but fair enough. All right. So with this, we can indeed bind also dynamic values. We can insert also from Figma, as we saw, from the web directly. We can create or we can add content from pre-generated AI templates if we want some more complex UIs. For example, we can add this pricing component. And also, and this is another very interesting functionality, we can add custom components. These custom components are the mapped components that we did before. So here we have the custom button, for instance. So that means that we can, thanks to this mapping functionality that we saw before, we can now also integrate these local code components into the layout here. So today the demo is really absolutely against me. All right. Sorry for that. So let's hope at least this works. I can grab the button. Yeah, good, this works. And then we can have here, for example, a custom button. So this is the button that we mapped before. It was the button that came from our code. And this is to show how we can then enrich a starting static mock extracted from Figma with also our local code components. And I can do that without asking my developers to do that. From this step, then, I can go on and switch to the develop mode and have all this part generated. This custom button will be referenced, not newly generated, or I can even publish it. With this, I can host this layout. Yeah, confetti. I can host this layout in Google Clouds from hosted by Builder.io, but I can even provide my own custom hosting space. But this is to show then how we can have these results live, and then I can share with colleagues so that they can go around, click. And as you can see, all these second demo steps didn't involve any technical know-how, didn't involve any developers. I can grab the mapped code components, I can grab the initial Figma mock, and then together I can even tweak with LLM when it works. I can enrich them, and then finally I can decide either to have it fully generated or to have it published here. With that, we reach the end of the session. Here is the QR code of the Figma mocks I use for the demo. It's a community file. That means that you can freely download and use it even on the desktop version. And with that, you can already start tweaking around and experimenting with Builder.io, because there is a free tier that you can use it and you can install it locally with the Builder.io plugin, Figma plugin. If you have any questions, I'm here around tomorrow as well. There are some stickers. I left it around. If you want also tomorrow or so, just come by, pass by, and any other questions or stickers, I can provide them. Thank you very much for the attention. I hope you enjoyed it, and I hope you can see now how you can save sometimes not working with the CSS and focusing more on the business logic. Thank you very much.